Hi, I'm Cassidy, and as you probably know, I really like playing rugby, so I'll be presenting on the optimization of conversion kicking. In rugby, the equivalent of a touchdown in football is called a try. A try is scored by crossing the ball over the end zone and touching the ball down on the ground. After a try is scored, in order to score conversion points, the kicker must go back on a line that is perpendicular to the end line from the point on which the try was scored. In order to optimize the angle from which to kick conversions from, theta must be maximized. In order to do this, I wanted to find the correct length of D, which is the distance from the try line, in which theta would be maximized depending on how far out the try was scored from the posts. One way to maximize theta is by creating vectors on the field with the labeled points. Then, using the equation for the angle between vectors, the cosine theta equation, you can create an equation for theta. If the derivative of that equation for theta is found using u substitution and then set equal to 0, an equation will result that maximizes theta given the distance p from the posts where the try was scored. The more exciting and visual way to describe this equation is through geometry. If a circle is imagined on a rugby pitch that intersects both posts, every point chosen along the circumference of that circle will create the same angle with the goalposts. As the circle's radius increases, the angle between the goalposts decreases. Therefore, if a circle is inscribed on the pitch that is tangent to the imaginary line on which a kicker must kick, that will provide the circle with the smallest radius and therefore the maximum angle of theta if they kick from that imaginary point of tangency. Using the Pythagorean theorem, assuming P is the distance between the posts and x, y is the optimum point from which the kicker should kick, an equation from a hyperbola can be found. This hyperbola gives the equation for y, which is the distance back from which the try line the kicker must travel in order to optimize the angle, given p, which is the distance between the posts, and x, which is the distance from the middle of the post where the try was scored. This is the same equation that would be found if the derivative method was used. To use this equation, numbers must simply be plugged in. If the try was scored 9 meters from the center of the field, x would be 9, and the distance between the posts would be 5.6, which is a standard number for all rugby pitches. This would mean that the kicker would have to travel back approximately 8.55 meters in order to kick from the ideal angle in order to score the extra 2 conversion points. And now you know, if you ever want to get really good at conversion kicking, you can optimize the angle.